Hello everyone, welcome to Tribe of AI for Medical Diagnosis. My name is Dovydas, and today is our 22nd meetup. I work in Vinted as Artificial Intelligence Team Lead. I'm also the founder of Tribe of AI, and I'm also a member of Artificial Intelligence Association of Lithuania. So first, let's thank our sponsors, Tech Consult, Vilnius Tech Park and Vinted. Those great people are helping Tribe of AI to stay productive and to continue to deliver you like these presentations and also Academy. So let me introduce what we are going to do today. So first, we are going to start with the introduction. I'll tell you a little bit about what is Tribe of AI, what we are doing. Then we will continue to the AI for medical diagnosis presentation. Finally, in the end, we'll have a short Q&A session, and also we can hang out in this in this audience tool chat. So you're probably seeing this link for asking questions. So please go ahead, use this link, ask your questions throughout the presentation. At the end, I'm going to answer your questions, and also we can talk about topics which you find interesting. So let's start with the introduction about what is Tribe of AI. So first of all, we have 3 products. We are doing meetups, we are doing bootcamp, and we are doing academy. Let's start with the meetups. So you are part of our already 22nd meetup, and it's the 4th remote meetup today. Meetups will continue to be online until the coronavirus threat passes. And it seems that we are doing pretty okay, even with these coronavirus limitations in place. We are still going strong and delivering good, interesting online meetups. I'm really excited about today's presentation about AI, like the role of AI in medical diagnosis. I expect that it's going to be interesting for you as well. We are also organizing bootcamps. In fact, our very first bootcamp finished this year after more than 9 months of really intensive studies. 9 people have graduated, and our new and improved bootcamp 2.0 will start this year. We planned to start it in September. However, due to the coronavirus again, these plans had to be shifted towards the end of the year. And I'll update you with more details about the bootcamp as they become clear. One more product which we are doing is the Academy, AI Academy. So the idea of AI Academy is that you can learn artificial intelligence with no prerequisite. And to make this idea happen, we have some principles. So first, we do not create the content. We are very, very practical. We aim to maximize your success rate. And finally, we try to use agile and lean principles in your learning process. So what does that mean in practice? In practice, it means that we organize these AI Academy classes. All in all, we have 7 classes, starting with the F class, which is mainly aimed at teaching you Python fundamentals. We have more advanced Python in the E class. We have data science in the D class, machine learning in C class, and so on. So depending on your current skill level, you can join any of these classes as they start. and you can continue your path towards the AI mastery. What's really interesting is that probably next, or like within like this between this meetup and the next meetup, we are probably going to have 2 more openings. So we will have a new so we'll definitely have a new A class, so advanced deep learning. If you feel that you have deep learning fundamentals already in place, so it's an amazing opportunity to join very strong group of people who have just finished their B class, and they haven't just finished, they are in the process of finalizing their projects, and during the next couple of weeks they're going to graduate, and it's an amazing opportunity for you to join them. Also, we are going to have a new C class, so if you have some data science experience and you want to continue towards machine learning, you can also join another very strong team who are again finishing their data science class, and will continue towards the machine learning. In addition to that, we might have another opening. So everything is going to be on our Tribe of AI platform. I'll announce everything, and I'll invite you to apply for these openings in the teams as they become available. So let me tell you a little bit more about what does it mean to be part of AI Academy. So we have we have some rules there. So first of all, you must commit to at least 8 hours per week. We want everybody to be really motivated in the academy. So therefore, by the way, 8 hours per week might seem not a lot, but it's a full work day. So take that into account. It's like working at least 1 extra day every week. We also have meetings every Saturday. So these meetings, their aim is not to teach you something, or actually it is to teach you something, but they are not, the main driver of your learning. These are mostly there for adjusting the course, for filling in the gaps, and overall making your fundamentals stronger. So during these meetings, we talk about your sprints, we talk about topics. How did your sprint went? If you have any questions or topics which you want to discuss, we talk about all of these things during the meetings on Saturday. The strengths of a Tribe of AI is by far the main strength of these AI academies, that we embrace the social aspect. I think that we started with different strengths, which I identified before the academy started. I thought that, it's like the content is very good. We take the most up-to-date and world-renowned courses, and we structure them in a way that they are properly, you have necessary fundamentals before you tackle the next step. However, soon it became clear that the social aspect is really dominating as the most important driver for your success. So therefore, it's most of the day by day or sprint by sprint, these social aspects became more and more important, and sharing knowledge and expertise, helping other team members grow, and making meaningful connections became the most important strengths of the Tribe of AI. So if you want to join us, you have to register to our platform. It's since last meeting, it became open. Now everybody can register. It's all the content you can, if you have some content which you want to share with your colleagues, friends, whatever, like you can post it on Tribe of AI and send the link to your friends. It's finally open. Search engines can access it, and overall we are moving out of this closed beta stage to a more open beta. It is going to be overall a place for everything what's happening with our artificial intelligence community. So teams, events, courses, everything is going to be there. So now it's time for the presentation, AI for medical diagnosis. Before we start, I want to say, like, well, the reason why I decided on this topic for this month's presentation. The main reason was the AI for medical diagnosis, so the same name course in the AI for medicine specialization in Coursera. It is from the same people who delivered the AI specialization. It is not taught by Andrew Ng, but it is taught by his colleagues. And I found this course really interesting. I learned quite a bit from doing this course, and I like, even though, you know, like those who know me, you know that I don't work with medicine, and I didn't like, it seems there are so many people in AI community who are targeting medicine, so I kind of found this field quite crowded, and I always targeted a little bit more, like my aim was always to go for helping the business, firms, enable them to use artificial intelligence tools. But like this course, like, to be honest, really got me inspired. I think that AI is such a good match for medicine, and it can do so much, and when you think about it, even if it helps a little bit, this help is going to be very significant for a large number of people. Even if you enable some kind of AI solution on a hospital, it is like permanently making this hospital more efficient, or the diagnosis more robust or more accurate, and it kind of really improves the life of the patients of this hospital. So even in this like very limited case, the upside is huge. So I encourage you, and the reason of this presentation is I encourage you to really think about your path in artificial intelligence. I might not go for medicine at this point, but I would encourage you to really strongly think about it. It seems that this is, like, as I said, a very good match for artificial intelligence. So let's continue. Our plan for today is, first of all, talk about artificial intelligence in healthcare. Like what's happening in this field, what are the successes, what are the opportunities, what's the current state of artificial intelligence in this broader field. Then we are going to talk about medical versus non-medical artificial intelligence. It's very interesting to compare the two. There are some similarities, there are some differences. I was personally quite surprised by how similar things are. I always thought that it's going to be quite different, but a lot of the tools which we use in regular deep learning applications, they, like, with some modifications, or sometimes even without any modifications, they can be applied in like medical applications. Then we are going to go for the medical diagnosis with artificial intelligence. So we'll talk more about what is medical diagnosis, what's the difference between diagnosis and prognosis, how this diagnosis, a little bit more practical, more technical details, about applying artificial intelligence for diagnosis. And finally, we are going to go for the ethical consideration. So it's like, it might seem like, oh, I'm just going to go and create models. And mostly in AI, that's not true. It's not enough to just go and create models. It's always very important to consider the ethical. What's like, how is your like how your deployed models, how we are going to affect the world. And especially in medicine, that's like paramount. You are doing this thing because you want to make the world a better place. So like, please go and think about how your deployed models, or how we are going to affect your patients or the patients of the hospitals. And are you really not making somebody worse off? So in any other field, it's important. In medicine, it's really, really the most important thing. So let's continue. AI in healthcare. So first, let's talk about the successes of medical AI. We have quite a few of those. And I just like, first of all, I thought like, maybe I can try to list all the broad areas where artificial intelligence is doing something in medicine. Then I quickly found out that pretty much everywhere people are trying artificial intelligence. So in the end, I kind of just handpicked the most important or the most interesting for me stuff. And wherever I got the links, I added these links to this presentation. So therefore, I'm going to make, by the way, this presentation freely available for everybody. So for now, let's just talk a little bit about each of these successes and what do they teach about how AI can be used. So first of all, this algorithm Zio-AT. So this thing is detecting arrhythmias. This company, it's by the way a company which delivered this project. So they are like their product is quite interesting. They had this like in this link you'll find a pretty good description like how they outperform their competition. But in fact, like the most important thing is that they can detect like pretty serious heart diseases, and they can detect if something bad is happening for you. And this I think heart diseases are one of the leading causes of death. So therefore, this diagnostic tool is really important, and helping people understand that if you have a disease and getting diagnosis for it earlier is very important. The next one is sepsis watch. So sepsis is again pretty bad and dangerous disease, and this model helps you to diagnose it. Then we have like X-ray diagnosis. This is a broader field where AI is used extensively. So chest X-rays are the most popular. X-rays, but in general there are like so many different X-ray types, and pretty much we can detect a lot of different diseases. So therefore, this X-ray field in general is really becoming like the main, like if not the main, but it's really one of the main success stories for application of AI in medicine. Then something a little like really close to that, but not directly in the X-ray area. It's the CheckBird. It's a pretty new model. It's like it's a network based on the BERT language model, which is pre-trained on medical documents, and it can label the X-rays, so it's generating labels for the X-ray photos, like pretty closely to what the humans can do. The researchers started with the Bluebird model, and which was pre-trained on medical documents, and they extended the model and made it generate the labels for X-rays, and they achieved really high F1 scores, so just a little bit worse than human experts. One interesting fact about it is that they used Facebook Translator to augment their labels. They translated the reports from English to German and back to get a little bit rephrased versions. So that's a very good, a very smart data augmentation method. So you can, your model has more targets, and this is one of the tricks of NLP, and they achieved this again pretty high score. Then we have this Gentle. It's a reinforcement learning model, which it helps deep learning find new antibiotics, and it uses reinforcement learning to do that. That's pretty, again, really interesting field. I encourage you to read more about it, and they're using pretty advanced mechanisms to do that. So finding new antibiotics, automated drug design, again, it's a pretty interesting model. They try to select the best candidates, the human candidates, who can it's one of the problems is that you can select the best people whose experiments are going to tell you much more about how your drug is performing. So therefore, it's not a big I guess breakthrough, but it's quite interesting application of artificial intelligence in this drug discovery in this drug design process. The final one is really interesting. So they made a model which, from the conversational speech, can detect signs of psychosis, and that's they say that the accuracy is about 80%. So that's really interesting. They train a neural network from a lot of the conversations, and they check based on the words that people use. They can detect if somebody has a risk to develop psychosis later in their life. So that's a list of successes. As you see, AI, medical AI, has really interesting and wide range of applications. Let's talk a little bit about the opportunities, and I think this is one of the most important parts of this presentation. How can artificial intelligence change the medical field? So first thing is the electronic health records. So this is by far the prerequisite. We have to have patient data. It's a precursor for everything else what we are going to do. If we don't have these, it's going to be pretty difficult to do anything else. Luckily, it seems that this electronic health records are becoming more and more widely used, and if you have those, so first thing which we can do is we can reduce the healthcare inequality. This is a huge problem. Rich people have access to much better healthcare than poor people. I guess that's pretty common sense. However, it doesn't have to be like that. If you have electronic health records, if you develop models, the models are cheap to run. Therefore, if we have like very good diagnostic models and we have pretty similar amount of data, it doesn't matter, like it doesn't cost you much more. You don't have to hire the best doctors in the world. If a model is the best doctor, the best diagnostic doctor, I mean, then you get the same level of diagnosis as everybody else. So making this thing cheaper and automated and more accurate and also faster is like again the goal of like if you can use AI here, it can make the models, can like ultimately it will beat the human state of the art right now, and it will outperform even the best doctors in the world as these models are being developed in the future. If we have, like, once we have that, we can move to much more interesting stuff, like more futuristic stuff such as at-home and real-time health monitoring. So there are like lots of, like, once we have like very strong diagnostic models, we don't have to go to hospitals to apply them. We can do that at home, and hopefully like even simple devices such as our smartphones, which have cameras, like even now they're used to detect skin diseases and skin cancer like instances. So it will become like, hopefully we will deliver and develop more and more of these models which can be used at home by everyone, which are accurate enough, and you know, it's pretty much a hassle to go to a doctor to check everything, and that's why people don't do it. But imagine if that would be as simple as snapping a picture on your smartphone, and your smartphone will tell you if this weird, I don't know, weird thing on your hand, if it's dangerous or not. Also, we'll have a real-time health monitoring. So like even now we have wearables such as Apple Watch, which track our heart rates, and it even detects arrhythmia right now with the latest version. So we can have many more of these applications, not even with heart, but like I don't remember which company. I think Google developed contact lenses which detect diabetes, and we can have more and more of these wearable technology which real time and which kind of constantly tracks our vital signs and detect something wrong. So doctor can see you for maybe 15 minutes per month. That's probably the average, or even less, like even average I guess is even less. And wearable devices can track your vital signs 24/7. So therefore it's like it has much more data to go with, and therefore it can make much more customized diagnosis. So that leads to the last point, personalized healthcare. So if you have a lot of data, if you have these like devices which are tracking our vital signs all the time, we can expect our medical models can be fine-tuned for us specifically. They can understand like how our body behaves, and this personalized information, this personalized data will lead to very personal and very accurate models. So these are like these, as you see, these things are chained, they depend one on another. So we have to have data first to like reduce inequality and have faster and more accurate models. Then if you have very accurate models, we can apply them real time. We can apply them at home ourselves, so that those like whole opportunities start to become viable. And finally, once we have a lot of like if we have a lot of real-time data, and we have like a lot of personal data, we can have very personalized healthcare experience. There are some problems which are hampering the progress. So first of these problems is there's really not a lot of public medical data sets, especially compared, like, there are so many other, like, okay, there are the data sets is still quite, in my opinion, still at its infancy, but there are comparatively much more data sets of any other field than of medical field, and there are, like, many reasons for that. So it's there are issues of privacy, security, and anonymity. It's pretty I guess it's pretty hard to fully anonymize all the data sets and make them public. You have to keep them secure, and like, never, like, these are very, very sensitive information, so therefore it's pretty difficult and pretty expensive to make them public and properly ensure their anonymity. There's also an issue of algorithm transparency. Medicine is one of the most sensitive fields about the algorithm transparency. We really have to understand how each of the algorithm works, or I guess more specifically, we have to have these diagnostic tools for the algorithms. So we have to understand what their behavior is, and how we are making the decisions. And finally, one of the problem which caused a lot of news quite recently is different equipment and procedural standards. So if you train a model which used a little bit different equipment, and you apply your model on in every hospital, so even small things such as a little bit different equipment, or a little bit different procedures of how things are done in different hospitals, so all of these difference in standards can lead and will lead to your model performing much, much worse than what you expected. And in the these bad cases, it will lead to misdiagnosed diseases, and that's, again, might not be very it might be a very costly problem in other domains, but in medical domain, it's really devastating. Let's talk about the differences between medical and non-medical artificial intelligence. There are many similarities, in fact, between those two. Most of the time, it seems that they are using quite similar methods, quite similar models, but they are looking at these things from a different point of view. So that's one thing which I would like you to, if you start learning or researching this field, think about that. At least for me, it was that these things are really similar to what we are doing in other domains, but we are treating it a little bit differently, because that's they have a different point of view in medicine. Also, we have a lot of knowledge transfer opportunities. So one of the most famous ones is the UNet. UNet was first developed for medicine, and later it became like the most important architecture for image segmentation in all domains. So therefore, I believe that learning about medical AI will make you a better non-medical AI developer, and vice versa. If you learn non-medical AI, you will be a better medical AI expert. So UNets and my personal ones, I really like survivorship models. I think that they can be used in much wider applications than just in medicine. So there are lots of opportunities to transfer knowledge between those two domains. So first, let's talk about the similarities. So in both of these, in medical and non-medical AI, we have transfer learning. The transfer in medical AI, we transfer on like if in non-medical AI, we are mostly using ImageNet as for our transfer learning models. So in medical AI, we can even use ImageNet for some type of tasks, but we can use different transfer targets, trained models trained on different data sets. So for X-rays, we have models for X-rays, then for other type of image like diagnostic imaging procedures. So there are like more transfer sources, however, which the idea remains exactly the same. We also have the weighted loss functions. So in both domains, we have usually we have unbalanced data sets. Probably I didn't encounter ever a data set which was balanced in real life. And in both of these fields, we have like various ways how to deal with the imbalance. We can try to balance the data, or we can use weighted loss functions. So in medicine, these are even much more popular because we usually have a lot of multitask learning opportunities. So like weighting the loss function appropriately is very, very important. We even use similar image convolutional neural net architectures, so such as Resnet, Densenet, Inception, stuff like that. We have similar or even same objectives, such as like we have classification tasks, regression tasks, segmentation tasks, things like that. We have similar augmentation techniques, or actually same augmentation techniques, such as rotation, brightness, contrast. However, like we have to be really careful about we have a little bit more limited range of options here, because like we cannot really do nor vertical nor horizontal flips, especially for any type of X-rays or any type of diagnostic imaging. However, there are exceptions. If you are using it for example, patch of skin to diagnose potential cancerous like thing on the skin, we can use those as well. It really depends on the task, but be really careful. Do not, humans are not as symmetrical as we seem, so you really cannot do horizontal flip and expect like your heart will be on the right hand side, so your models will be totally confused. Finally, we are using things such as stratified train test split. We really need to ensure that the right ratios are in, especially test and validation data sets. These must have enough samples of a less popular labels. So it's important to do proper train test validation splits. There are some differences as well. So if in like non-medical AI, we usually talk about precision and recall. So in medical AI, we usually talk about sensitivity and specificity. What's quite interesting that sensitivity and recall are exactly the same thing. They just have different names, and therefore, remember I mentioned that the ideas are quite similar, just different point of view. So this is the perfect example, or I guess the easiest example of that. These are exactly the same thing, they just have different names. By the way, specificity and precision is not the same thing. They are a little bit different, but they kind of represent the same idea. So like how sensitive your model is to a disease, and is it only how much false positives is it producing? So we have this difference. We also have 3D images. That's kind of new, right? So these CT scans generate 3D images. There are multiple ways how we can approach to solve them, to use them. So we can use them as pretty much just a lot of 2D layers, and we can also go for the 3D approach, where we pretty much use slice the 3D image into a lot of smaller 3D cubes and use them for our as inputs to our 3D convolutional neural networks. By the way, these images are pretty huge, so therefore they don't fit into just one GPU or even in the RAMs of regular computers. So therefore we have to figure out what's the best way to slice these images. As the size of our RAMs and GPU RAMs are constantly increasing, and it's easier and easier to use multiple GPUs with one on one machine. So these problems are becoming not as important, but as for now it's still required to choose one of these approaches. We also have image registration problem. It's when you do a CT scan and you pretty much go do multiple iterations, and you have to realign if your patient moved while you're doing these scans. So you have to realign different channels, and this channel alignment problem is the image registration problem. So it's still something that you probably never do with regular non-medical AI. We have very unbalanced segmentation tasks, and that's, by the way, that's not super new. We have in non-medical AI we sometimes have very unbalanced segmentation tasks, but in medical AI that's usually that's pretty much always the case. So you have to detect very small segments in much larger images. We use the soft dice loss for that, and it's robust against the very unbalanced segmentation tasks. Let's talk about the medical diagnosis with artificial intelligence. So first of all, what is diagnosis and what's the difference between diagnosis and prognosis? So diagnosis is when you identify if a patient has a disease, or out of 5 diseases, which does the patient have, and prognosis is predicting the development of these diseases or one disease. So in diagnosis we usually solve for this classification or sometimes regression tasks, but in prognosis we usually solve for estimating how what's the likelihood of death, what's the likelihood of a really huge increase in the disease, so in X years. So these are very different tasks, and today we are going to talk about diagnosis. The areas which AI is quite popular are dermatology, ophthalmology, and histopathology. So dermatology is about skin, so skin diseases. These are quite popular target for artificial intelligence, because you can make skin photos, even as I said about moving towards the at-home diagnosis. We can do skin disease photos with our cameras on our smartphones. Ophthalmology is about eye diseases. So diabetic retinopathy is one of the good examples of a disease which is targeted a lot by artificial intelligence research. Histopathology is the microscopic examination of whatever tissue we have in for us to find or segment the disease. So the first one is about the skin, second one is about the eyes, the third one is about the microscopic imaging. We have like a list of diagnostic imaging procedures. So pretty much all of these are used together with artificial intelligence. The most cheap and easy one, the easiest one and the cheapest one is the X-rays. A little bit more advanced is computer tomography and ultrasound, and then we have, of course, magnetic resonance imaging or MRI. So this is the type of medical images which you can expect to work with, and this is the type of data. These are the methods how your image data are generated. One really interesting fact is how the ground truth is generated. You cannot really, like this medical field is usually like the diagnostic part especially is like quite difficult to say with absolute certainty somebody has a disease. So there are multiple, it's pretty difficult to determine what the correct label is. So like the approaches to that is first of all ensemble of human experts, or even a single human expert sometimes, but usually an ensemble. So few humans talk about, and they either do this majority voting, so like which label has the most votes wins, or they talk about it and discuss the problem until they all reach exactly the same target and they agree on the label. Then we have pretty, I guess, intuitively, we can take and use more advanced equipment. So if we want to train a very good model on the X-ray scans, we can use MRI scans, which are more precise and which gives us more information, or CT scans, and to use that to determine the correct labels, and then train the models on the by getting this information allows us to get the labels, and we don't have to use it. We don't have to get a lot of the MRI scans. We just have to get the right label for it. And yeah, finally is conducting multiple experiments. So if the ground truth is not clear from just a single image, we can always go back and do multiple samples. So by the way, this is just for determining the ground truth, for creating our initial data set, and once the model is fully trained, we can benefit from this more for better labeled data, and maybe from more different examples. We have some key challenges in the diagnostic for the AI for diagnostic algorithms. I already mentioned class imbalance. So that's very, very often the case that we have very imbalanced classes. We have a lot of people who don't have a disease, and we only have a very small sample usually of people with the disease. We also have, if we are using one type of test to detect multiple diseases, their ratio can be very different. So somebody if in the X-rays we can have one more popular disease in 20% of the cases, and some very, very rare disease just in a few percent of all of our total data set. We have very large image sizes. I already mentioned that. We have these the huge images already mentioned, 4D images, and finally the multitask learning is we are doing a lot of the times we want to detect multiple things. We don't want to run the test again and again and again for every single disease. We want to run like a few diagnostic models and detect a lot of the disease at the same time. I have a list of resources which I found. So for today's research, these resources like really helped me out a lot. So first of all, we have this book, Machine Learning in Medicine, Practical Introduction. Very relevant, very, like, I can't say very interesting, but quite useful. AI for Medicine, so the Coursera specialization. So this is probably the most recommended one. Like more articles and papers about artificial intelligence. And finally, this quite interesting article, It Takes a Planet, about like the future of healthcare and what can be done to improve our healthcare. So let's end up with ethical considerations. I mentioned that this is the most important part. So first of all, it's really hard to agree what's actually fair. Like I initially thought, okay, so doing trying your best is fair, but like even like not even being a data scientist, but even agreeing what type of analysis you have to do. Like, would you send if you have a 1% probability for a person having a disease, would you send them through very expensive other diagnostic procedures? It's also very hard to notice unfairness because our data is like biased. As always, data is biased, especially towards the more popular classes, the more popular samples, the more popular categories. So we have to think really hard to find ways how to mitigate this built-in data unfairness and how to make our models behave like comparatively for all of our patient classes. Especially we want to avoid the model from learning the wrong things. So like if we have something which is not like causing the disease, but it's has some correlation, so it's very easy for our models to learn this as a predictor. Finally, we have to be, again, like think about the other flip of the coin. It might seem a good idea to regulate this field as much as possible, but we have to understand that if you regulate too much, we pretty much stifle the progress, and all of the good things which could come from using artificial intelligence in medicine, they are going to arrive later rather than sooner, and this late arrival will cost the human lives. It will cost in misdiagnosis. It will cost in extra diagnostic procedures, which is both a hassle for the patient and also expensive. It will cost in misdiagnosis. It will cost in inconvenience for people who have to go to a hospital. That like if he had these models which we could use at home, they could use these things at home, and they probably won't go to a hospital if there is like a really low chance of them having the disease. So overregulation might seem like the obvious, or regulation might seem the obvious answer, but the overregulation is as harmful as not enough regulation. And finally, let's think about the ethics and medical AI is like more about like how our data is used. So it's very important that the patients can consent and they are informed to what they understand, what they are signing up for. They have the right to choose if they want to use like what kind of procedures they want to use, and what kind of models we want we want their data to be used for. So it's very important that they have this ownership of their own data, and their privacy is still remains. So this is what I want to leave you with, that thinking about the ethical part of how our medical AI and ethics, these in my mind, these are, it's like, if not the most important, but critically important piece of the puzzle, how we can make our, how we can really enable AI in the healthcare. We have to really think about the ethical part and make our algorithms fair, and make our users and patients understand what type of what's done with their data, what type of models we are using, and things like that. So now let's move to the Q&A part. So let's see if you have any questions. I see that Kevin said that I didn't mention the start of a new e-class. Yeah, Kevin, the e-class will start probably in a few weeks after the current F-class finishes. I'm not sure if that's going to happen in the next month. So I didn't mention that, but probably it's going to happen during the next month. So there is a very high chance that we are going to start yet another one more class, so for the E-class. Also, Kevin asks, so which country is the most advanced in the use of AI for medical applications? And maybe, you know what, I'm going to switch to the questions. It's probably going to be a little bit easier just for you to see. So that's a very good question. It is actually throughout the world. It seems that a lot of the countries are experimenting with AI in medicine. There are lots of research, and you know, it's pretty amazing question. I don't have the answers right now. I know that even Lithuania is doing a pretty good job. One of the also members of the AI association, Occipit, they are really a success story, a company which is working with X-rays, more specifically various types of chest diagnostic imaging, and they are detecting various diseases, also generating reports based on their diagnosis. So even small countries such as Lithuania have pretty interesting and successful startups, but probably, as always, the United States is most likely the leading country. So any more questions? I'll give you a couple of minutes to think about them. Yeah, and these questions, you don't have to go for something really smart. If you have a topic that you want me to tell you more a little bit more about, or which you want to discuss, you can also add those. And I know it's pretty like it's not easy to write post a question while everybody's watching. So if you if you remember a question later, you can always post it to our tribe of AI, to this event. It has a comment section, so you can always post your questions there. So the last minute, last chance. Yeah, so I don't think that more questions are coming. So thank you all for being here today. I really hope that you will think about learning more about artificial intelligence in medicine. At least for me, that was really great, a really interesting field, and really fun, fun topic to research. So see you during the next meetups, and bye-bye.